Well, welcome everybody to the room. Make sure you have enough room around you, you will be fine. Welcome to this session where we're going to talk about Tetration, Tetration, which is a new product from Cisco. So good news for you, you made the right choice to be here for two reasons. The first one, it's nothing like Cisco does usually. Second one, there's an Xbox to win at the end of the session, so your chances have just dramatically increased. So good for you. I'm Remy. I work for Cisco. I work in a team which is called INSBU. We do switches like Nexus 9K, Nexus 3K, ACI, Clicker, and a new product. And this new product is Tetration. So we're going to talk about a few things today. First one is, well, why did we build a product? Because you may guess there was a kind of reason why we did that. Then what it is that we built. What it looks like in terms of architecture and so on. And just not to scare anyone, there's nearly no Cisco hardware in this presentation. Compute and application is what we're going to talk about mainly in this session. And finally, I'll show you the system. So I have an environment that I built. It's based on Hyper-V, Microsoft event. We do something around Microsoft. And it runs with no Cisco hardware, with the exception of UCS servers, just because, well, we buy them cheaper internally. That's the only reason. So let's start. What's happening really in our environments today? And the thing is really, there's been a shift in the way the data centers are working. And we've seen it happening over the last few years. First one, of course, is big data. Big data is fashion. I'm sure everyone has some kind of big data system set up, or even just experiment running in their environment. Now, all those systems are great, love them, very useful. Problem with those systems is that they don't follow the regular traffic patterns that we see in our environments. Usually, traffic, historically, we'll put it this way, was around 80% north-south, so very easy to catch, very easy to limit. Just put a firewall, put an IPS there, you're done. Now the problem is all these systems work with kind of like Zookeeper and Yarn and all those, talk to different systems to arrange themselves to work and to get something going. So instead of going from the north-south, we're now going east-west everywhere. And I've been seeing that as well with all the Microsoft applications and so on, like remote desktop, that's the application I set up for the demo. Those are the things we had around that. Next one is, of course, open source. Open source is a big thing. We're supporters of open source. The problem with that is the governance of the projects. The problem with this governance is that you don't know what you're going to get, basically, in terms of code. You can go and you can open it, you can extract it, you can have a look through it. But if I decide to commit something that's wrong to a repo, let's say, for example, I decide to commit a backdoor that's sending all traffic back to my home server, well, you can't see it without actually inspecting the code by itself. So those are the few things that are kind of in the shift inside the data center. After we got the cloud, like we heard about it, Azure is a big thing, Amazon is a big thing. Everyone has some kind of on-prem, off-prem kind of data in their environment, which is a good thing. The problem is how do you enforce and control policies down to those environments? You got security groups on Amazon, different flavor on Azure, and again, different flavor inside your environment, Palo Alto, Asa, whatever you're using. Each one has their own kind of language. So how can we understand what's happening there and put the policies at the right place wherever the workload is? And finally, rapid app deployments, DevOps, and so on. You can put in all the fancy names around that, continuous integration, continuous development, microservices, all those kind of things. The problem that comes with those is that, well, developers go much faster to production. Network may not follow depending in your environment. If I push something that uses a new port, for example, most likely I'm not going to tell the application team because for me it's pretty obvious it's going to work. Well, here you are, network down. So when you see all those, we needed some way to regain visibility inside the environment because there was no option. We could span and tap. We're talking about bandwidths which are going now to multi-hundred gig per server. So we're pretty kind of beefy things. So we need a way to be able to trace and to understand all that. And that's the reason why we built Tetration. And a few things on Tetration before we actually go into the platform. So Tetration is a completely separate team inside Cisco. So there are different offices, different places. There are different kind of skill sets that are there to solve the issues that we're looking at. And that's the reason why we're actually making this shift to application kind of world, which we weren't really in right now. For the Adignot, Tetration is the hyper-exponential, so that's the reason we process and store a huge amount of data, hence the name that you see on it. So what do we do? Because it's good, we've seen some problems. What do we do to solve those problems? And there's a few things we can do. The first one is we gather information at the network level, and that's one thing that's important. And then we contextualize this information with server-based information, process, or load balancers, or things like that. So we take all this information in. Why? Because a flow by itself doesn't mean anything right now. Microservices, if I start an application on port 443 service A, half an hour later, this service could be running service B. There's no way for me to know at a network level. So you need to be able to see what's happening in your environment. Then once we see what's happening in the environment, we need some way to be able to search through it and to look through it. The classical problem, something went wrong in your environment. You try and troubleshoot and so on, everything is working now. Those are the things that happen every single day. You go to the network team will come in, they'll say, we're going to span or we're going to tap for a few days or hours, depending on the capacity they have, to see if the issue happens again. Of course, the issue never happens. Stop the tap, you're done. Too late, issue reoccurs straight after. That's kind of the classical thing that happens. So our idea is to say, you know what, let's use the span tap kind of idea, but let's store continuously the data. So actually, everything that's going through your environment, all the flow information is being stored on the Tetration appliance. And you can search through them in a very easy way. Why do we search in an easy way? If I do a query, and the query takes 15 minutes, each time you do a query, no one is ever going to use this platform. That's for sure. So what we did is we built a big data environment to make sure this doesn't happen. And for this not to happen, we have an environment which is using heavily SSD and RAM to make sure it goes extremely fast. Things, once we have all this data, like, what do we do with it? That's kind of a big thing. If you take Google, value of Google is in the data, but it's only as good as you can do a very, very easy and simple query. If you can't, no one's going to use Google. Or same goes for Bing and others. Then the first thing we want to do with it is understand the applications. And that's why we're insisting on the fact that this is really application focused. We take data from the network, but we really focus on the applications around it. Why? Well, I don't know how it is in your environment, but each time I talk to the IT guys in Cisco, they always know their environment. And they always come up with a map, and they always show me their application, and they always tell me that's how it works, and so on, which is okay. And when we do acquisition, it's always the same thing. It's company X that we acquired. Here is the network diagram. Here's the application diagram. So, okay, great. What we figured out is that that's rarely the truth. Is that they often have a picture of their application. They often think it works like that. But as long as it works, then there's no need for them to go and look further. So what do? They just keep the application diagram, and then you find very funny things. I'll give you an example in Cisco. Once we started Tetration, we deployed sensors and so on, or on the workloads, give it to Cisco IT, compared Cisco IT application view to Tetration view. You know, there was a flow that didn't make sense. One server was talking to another server. Outside of the usual traffic path, this flow was not on the diagram. First behavior we have is, okay, new product is definitely a bug. So we go back to engineering, start looking into what went wrong, look into all the details, and we see that flow exists, we see it. Go back to Cisco IT, no, sorry, it works like that. For sure, I guarantee you it is like that. And what happened, in fact, is the application guys had an issue on the network, in the environment. They had to fix it. So they just put a static route to route directly to a server, kind of a host route there. Works, problem solved, case solved. No one ever came back to change it. And that was like 8 months before we did the analysis. And those kind of things happen every day, and we have like hundreds of examples just within Cisco there. And I'm sure you run into the same kind of problems in your environment. But then once I have an application map, same question as usual, what do I do with it? That's the whole point again. Well, I have a nice picture, copy paste it in a PowerPoint, you have a management level kind of dashboard, everyone's happy with it. Now, how do we make something useful out of it? And the first thing we want to make out of it is a policy. If we see what's happening on the network, and we have the processes, and we know what's listening where, and whose process is using which port exactly, I can create an absolutely perfect policy for every single application. So when an application vendor comes in, and we're the same on this point, so I'm not bitching about anyone, the problem is that they'll tell you open port 30,000, 65,000 on all your firewalls. That's the kind of usual answer, cover for RPC, cover for all those things there. Now, of course, security, like InfoSec, usually will tell you no way. And how do you know what do you really have to open? And that's the reason why we want to derive a policy from what's actually happening in the environment. And once we've put this policy in, well, we need some way to check it. Because it's good if I have a policy in my environment, but if I have no way of checking if this policy is actually doing something for me, it's again useless. And the idea is to say, I want to check my compliance to real traffic, I want to check my compliance on historical traffic, and I want to test my compliance before I deploy a policy. And I already see everyone must be thinking, yeah, okay, he's going to sell me an AC firewall or something like that. Again, no, we do export those on a standard JSON format, so you can put them anywhere you want. This platform is completely not tied to anything Cisco. And that's one of the big shifts we're doing in our BU. So now that we have all those, so that's really what we are trying to solve. Those are the issues, and that's what we're trying to solve today. Now, I let you imagine with the data we have, we could do much, much more. So that's really what we do today. And how do we do it? And we do it actually, there's a few things we do. The first thing is we collect information, we pull information out, and we pull information from two ways, a host sensor or a network sensor. So why do we do both? First thing, you might not be running Cisco. It happens. So we need a way to come into your environment to bring some kind of value to it. Then the second thing is that when I can have the best network solution in the world, I still won't see a process. That's the thing. I need to sit on the host to see a process. And that's the only way I can get that working correctly. Because again, the flow by itself doesn't mean anything to me right now, especially in the future, less and less. So we have a sensor. Guess what? It runs on Windows, 2008 onwards. It runs on Linux. And I have a hardware sensor. So let's say you are a Cisco shop. We have inside our switches a specific ASIC. And this ASIC does everything that I'm showing you and I'm talking about in hardware, except process information. But it gives you some extra information. Then we ingest some third party. And again, we're not the center of the world. Some other things are happening in your environment. Load balancer, one of the big ones. You probably have a few of them in your environment. They might be of different vendors. You might have global site selectors. You might have, hopefully, DNS somewhere, IP address management. All those information are things we want to catch and we want to store on the platform. Why? Because guess what? We are using machine learning. So the more context we have around something, the more information I can fill into the platform, the more accurate my algorithms are becoming. And when I show you in the demo, you'll understand what we do with this information. So I take all this, I stream it into the platform. So first thing to note, we are streaming the telemetry information. So it's not a kind of push-pull model or a kind of thing where we do massive caching or things like that. This is streaming telemetry. Don't worry, we don't consume a lot of bandwidth. I'll show you in the UI. We're between 1% and 2% of the actual traffic bandwidth. And that's numbers I can back out with Cisco production environment there. And so we take all this and we put it into our custom-built appliance. And this appliance is running a Hadoop environment, but that we built. It's not one of the Cloudera, Hortonworks, or others. We're really having our own distribution that we built. Some components which we actually recoded or optimized to meet the performance. We're talking networks over 1 million events per second is not something that's abnormal in this kind of environment. And then all this, we store it, kind of Simple. So on the box by itself, again, no kind of external storage required, anything like that. Everything is self-contained as an environment. And once we do it, we expose it in some way. And this exposition is done by 3 different kind of interfaces, depending on the kind of users you are. If you're a data scientist, for example, you're probably going to go for the REST API in the Kafka stream, and you're going to go and connect that to your environment. Kafka, for the people that are not aware of, is a pub/sub environment. So I subscribe to events I'm interested in, and then the platform is going to stream those events out to me when they come in. So it's a kind of way of getting information there. But now, not everyone is a data scientist, or everyone will be rich in this room, or maybe we are, I don't know, but it's not my case anyway. So we got a web UI, and the web UI is tailored to the roles of the people that are actually using this platform. So the app owner, the network owner, and the security teams. And they have each one a kind of environment that suits their different needs. Few things I didn't say yet. You don't need any kind of Hadoop background to run it. This really runs as an appliance. So when it comes as a rack right now. There will be other form factors in the future. So this rack, you just connect a laptop behind it, you upload a file, you press enter, you go for lunch, you come back, everything is up and running. That's all you need to do on this. Management, same thing, no crazy management you have to do on this thing. It's completely automated in the background. It's going to throw you alerts when it's not happy. So we really made it as simple as possible to use. Then let's talk a little bit about the sensors. So we talked about sensors. We got different types of sensors. Some of them are available today. Some of them will be future, as usual. There's still an M of marketing in my title, unfortunately. So we got things available today: Linux, Red Hat, CentOS, Fedora, Ubuntu, all those flavors. That's fine. SUSE Linux coming by the end of the year. We have the switches, of course. The ASIC is ready. So if you buy anything that's 9200X, 9300EX, 9300EX is the ACI switch as well. So you're fine. NXOS or ACI, that works. And what we're working on is hypervisors and containers. It's a big thing right now. We didn't go in hypervisors now because it didn't solve any issue for us. The reason for not going to hypervisors is simple. I still can't get any process information in the hypervisor. So it doesn't help me a lot. It gives me a little bit more visibility, but not the visibility I'm ultimately looking for. Those sensors are highly, highly optimized. I mean, literally piece of art kind of software. And I'm French, so for me to say something positive, you have to go really the extra mile. So it is absolutely perfectly optimized, and we're talking at 0.2% of a single CPU core in terms of bandwidth usage. That's what in terms, of CPU usage. So, and this is production numbers I'm giving you. Again, not lab QA kind of thing there. And traffic-wise, what we see in Cisco IT is below 1% on average. We say 1 to 2% is what we expect in any environment. They are highly secure. Like, we're getting information which is pretty interesting. Let's say that if someone managed to breach the platform, they would get recon in your environment very easily. So we do acknowledge that, and that's something we worked a lot on. So we got lots of mechanisms in place around the PKI that's deployed and embedded inside the platform. And many more things, of course, SSL, TLS, and all those things, as usual, are running on top of it. And the one thing which is a bit different, we focus on every single packet. In the sense, I'm not interested in the flow by itself. I'm interested in every single packet that make up a flow. Why? Steganography. That's the reason why, amongst other things. And the problem with that is that if I try to exfiltrate information out of your environment, and nowadays I just open the newspaper to find a breach that's really on a daily basis, if I can't see this level of granularity, I don't know what's really happening in my environment. Because if I just flip a bit every packet and just no one is going to see it across the environment, not going to make any payload change, and this may be pulling data out of your systems. And against that, sorry, more than that, even routing interception. Those are things that are becoming that happen quite often, we'll put it this way. The problem with that, what happens is that we inject a route to redirect your traffic. And then, well, no way to see it. Your traffic is working. I'm just copying it. And if I can see every single packet, those are things I can detect. So keep in mind, again, 0.2% of a single CPU core for checking every single packet in your environment there. So that's why we really did a huge effort on that part. So then the few features of the sensors. We never sit in data path, whatever the case there. That's a choice we've made. In the ASIC, it's a separate module. On the server, we tap into WinPCAP for Windows, libpcap for Linux to get the information. So it's a copy at the driver level that happens. That's how we maintain the performance level. And the reason why we don't want to sit in traffic path is, first of all, we don't want to break anything if the sensor goes wrong. So that's one way we can do it. Second one is security reasons. If I'm not in that path, I cannot be fingerprinted ever. No one knows that I'm running there. So it gives me an advantage over the attackers. I see things that he doesn't know I'm seeing. We get all the flow information that we talked about. And one thing that's really important is how we collect information in this one. And I'll go directly to how we process the metadata. And we collect metadata on purpose. There's a few things, especially true in Europe, there. When you start touching to things that are related to privacy, people get very picky. I'll put it this way. Germany, quite a bit. France, a lot as well. And so the problem is that if I'm exporting information, I'm monitoring network. I'm exporting information out. If I happen to take a little bit of the payload when I export information, I might be copying the web address the user is looking at. We'd love everything to be SSL encrypted, but we all know that it's unfortunately not the case. So if I see this, I'm capturing private information on a user. If I'm doing private information, then my platform is submitted to privacy laws of wherever country you're in. Now, we wanted to avoid that at any cost. And to do that, what we do is we actually process every single packet on the host or on the ASIC. And the reason we do that is that we pull exactly what we're looking at, that we're interested in, from a packet, not more. So all this processing is done on host in the sense that when something leaves the server, I can guarantee it's never going to hold any kind of user payload information there. So that's a pretty big thing. Again, thinking about 0.2%, and that's all what we're doing for 0.2%. So it's a real bargain at this point. More things, the usual feedback we get on sensors, yeah, just put it on the list of the 40 other sensors we have running on the host. That's kind of the feedback we get. So good news, again, low CPU usage, that's the first thing. Second thing, you deploy, we manage. That's the deal on this. And what do I mean by that? That you use Chef, Ansible, Puppet, System Center, IBM Tivoli, whatever you want to use to deploy it. But once it's deployed, we take over the control of the agent. Upgrades managed from the cluster. Configuration managed from the cluster. Meaning that there's actually, to make life simple, there is no configuration file on the sensor. So there is nothing you can configure even if you wanted to. Everything is pulled from the central server. The sensor can only talk to one server, which is his cluster, because of the certificate process that we put in. In this way, once it connects, it gets its configuration down. You make a change of config, the config is pushed down. It's not a pull model. Few benefits of that, we don't open any ports on the server there, meaning most likely you won't see any issues of agent conflict because where you're sharing ports or things like that. Those are things we have worked on, and that's not happening. And the connection is always established from the sensor to the collector using 2 ports. That's the total thing we use. So again, security guys, don't freak out. We're not going to open all the network out to be able to send information. 2 ports out to 16 IPs address is all what we need across to set up the whole environment. And the few use cases that we want to solve. And those are the last 3 or 4 slides, and after we go into the UI. The first one, the biggest one, of course, is around forensics. We can go back in time. Any data that's stored on the platform, you can go back. And that's been pretty useful. And the reason why it's useful is that, let's say we've been breached. We want to check what happened, and we can understand what happened. We can also create a policy and see if this policy would have blocked the attack. And those are things that you cannot do today. You can only infer, okay, maybe the policy would have stopped the attack. Second thing, and you'll see that in the UI, we see every single flow. So it's a kind of Wireshark interface that we have. So it's kind of continuously running Wireshark. And you get nice diagrams for policy analysis, what is out of policy, and so on. So you get all this information out of the platform directly. Then troubleshooting, of course. If you're the ops guy and you got to get this thing out there and you got to troubleshoot a network, it's always nice to be able to go back in time and say, oh, you know what? There was no traffic from your server. So maybe the problem is linked to your server directly. And I think we refer to it as the mean time to innocence. That's how we call it inside the BU. So if you hear me talking about MTI, that's what we mean. And the idea is how can we understand exactly where the issue is in a very short period of time and not playing the kind of game, not my fault, his fault. And then the idea is to bring facts to get to this point. Then we can explore flows, and I'll show you we have pretty neat things, like we use machine learning to identify outliers, and so we show a list of flows, and then we ask the system, what do you think is wrong? And the system will then show you, point you, have a look at this system, this doesn't seem right in the environment. And then non-compliant behaviors, I'm sure that happens in your environment. Someone configures Google DNS on their servers, works well, but then after they want to join Active Directory, it doesn't work. You don't understand why, and you end up having to log a case, troubleshoot the issue, and so on. So those are things you can see directly inside the UI. Then everything that's related to policy management, and I go quickly through that. So create a whitelist policy model. So move away from the old kind of, I won't say legacy, it's a bit too strong, model where we just block what we don't want to block. The idea here is allow only what should be allowed, and all the rest should be blocked by default. Then we monitor this compliance and this policy, of course, and then we can derive it to ACI if that's what you're running, or any other policy engine that you have. And that's a key point, again, not tied to Cisco environment. If you don't have anything Cisco, you're fine with it. And the policy would look like that, and in terms of diagrams. You'll see, once I'll show you, it's going to be a bit more, the diagram is dynamic, so when you use your mouse, it makes a bit more sense around it. I'm going to show you that in the dashboard. This is one of our production applications in Cisco there. So this one is reflecting 5,000 endpoints, what you're seeing there. So that's all the communications between 5,000 endpoints that are shown in a simple diagram. Then application map, of course, this is the base to our policies. Kind of classical use case, identify single point of failure. You got a mail server, every management system is sending information to one mail server goes down, no one will know it went down. So those are things that we do monitor, and we can tell you, you know what, be careful, because this thing is not as per your policy or other. Identify dependencies. If you have a project of moving some things to cloud, you may want to understand how it works inside your environment. You might not want to move a system, for example, in the cloud, and then after notice that, in fact, there was a traffic of 10 gig that was happening between the server and some other systems there. That might become a very expensive bill at the end of the month otherwise. And again, undocumented applications. Let's say that acquisitions, these kind of things, are the kind of, you know, the timesheet kind of application that no one ever maintains, and everyone looks at the reports, no one knows how it works exactly, and you have to move it at some point. So all those are the kind of things we're trying to solve, and we do it, again, in a simple UI format. This is 5,000 servers again, so sorry, 4,945 to be precise. It reflects also more than 30,000 IP addresses, and those are the end users in there. So you see, I've managed to bring that down to a relatively simple diagram that's there. And again, that's a production application that we're running within Cisco. And you know what? Just out of this diagram, I can tell you that there are a few things that are wrong in our environment. First thing, well, actually, big thing. You'll notice on the right side, you got DB NPRD, DB PRD. We, in our rules, let's say, our management rules state that a production system should never talk to a production and non-production system at the same time. It should be one or the other. Guess what? This one is talking to production and non-production. And you know why? That's actually, it's a very, very kind of stupid thing. Happens every day, unfortunately. Developer hard-coded the IP of the development server. It works. And you know what? We sync the database all the time, so no one sees any difference there, except performance. The development cluster is 2 servers, the production cluster is 16 servers. So of course, people were there opening cases, my application is slow. Yeah, okay. Administrator goes and check the production database server, works well, no slow queries, nothing. No reason for me to do anything there. Yeah, except you were checking the wrong server. And those are things that we see every day in our environments and that get fixed over time, but that we don't know what's really happening. And that's how we're trying to bring back the visibility inside those environments. But let's have a look at this platform. So first thing you notice, we're not using Java, we're not using Flash. So it's big progress for Cisco. We are finally moving to HTML5 UIs. Second thing, it actually looks nice. It's actually usable. So those are things, again, we're learning from our mistakes. And we had lots of feedback with regards to ACI and APIC for the people who used it. And those are the kind of feedback that we ingested to build this kind of application there. So here, I built a test environment for this. And the idea of this test environment is it's a remote desktop services environment. And there's 2 environments in there. One of them is the virtualization layer. Everything is running on top of Hyper-V, so the Hyper-V environment. And the second image is kind of the actual user environment. So how do I access RDS? What is running? What is the RDS actually talking to? And to do this, all what you see here has been done by the system. I've just tweaked it. The system is there to do 75% of the work and leaves you the last 25% to do. Why? Because there's always things that we won't know about. If your server is powered down, it's a cold standby, we're not going to go very far with that. We can search for it on the network, most likely we won't find it. So there's always some kind of input we're looking for from the users. And then those inputs are creating the groups that you're seeing. Every single box there that you see on the left side is a server grouping. So we got multiple servers within every single box there. I can ungroup them if I want. Let's see if the network, yes. So of course, diagram becomes quickly much more of a mess. And that's the idea. As an application owner, I don't care about the fact that your RDS system is a broker and is a gateway, a web, and so on, and a host. It's not my problem. I care about the box, which says it's an RDS system. And that's what I'm looking at, and that's why we just grouped. Now, as the maintainer of the RDS system, you're probably more interested in understanding what this RDS system is actually doing right now. And that's what it shows here. And for each of those communication patterns, you can hover on the link, and you will have all the ports. You can go in more details for each of them. For example, here is actually the communication between the RDS host and the Tetration cluster. This is what we're showing right here. So here, you can actually see that we're providing service on port 443 and 5640, and that's the information you can actually get out of there. Now, the Hyper-V environment. In the same idea, I can do that. I can map multiple applications within one environment. Simple maps again, so you can get an idea of what's running, how it's running in the environment. So you get all this out for you. And then we derive all the policies out. And the policies may be pretty gross, because there, for example, we're looking at subnets. So I'm looking at the communication between each and every subnet. But the benefit is that we have data, we have the granular data inside this platform. So we can actually go down and look into what's happening at every single level. So you see this big one is actually my lab subnet. That's there. If I double click, I can zoom in into my lab subnet to see what's actually inside the lab subnet. And then let's take, for example, which one could we use? Active Directory. I can zoom in to see the actual communication patterns of every single endpoint that's inside this environment. So again, I started at a very high level. I get the subnet. So even if you want to step one step higher, I start at the application level, where I don't have any idea of what's running under it. I just get a linkage between different kind of boxes, different systems, and different group of systems. Then I can go down. I can see how subnets are communicating. Then I can see which groups and server groups are part of which subnets. And then for each server group, I can see every single host and how every single host is actually communicating inside it. And then you can see those are my 2 Active Directory servers. I can see the communication pattern for each of them. And as I hover, I'm just going to show what I'm interested in. You can see very easily how that maps out. Another thing that's interesting, you see the width of the arc on the side. That's actually relative to the volume of traffic there. So I can see from there, my big talkers in this subnet are my Active Directory, which was kind of expected because I'm focusing on them. And I can see how they're communicating with different other ones, Hyper-V being apparently the biggest consumer of the Active Directory services in this environment. Then for each of them, I can get the details, as usual, which are, for example, the kind of important processes running on the server, or every single port that's listening on the server. And you notice I have ports that are being listened at. Some of them are grayed out. And the ports that are actually grayed out are the ports who never saw any traffic come into them. So it means in this view, looking at it, apparently the DNS system on TCP 43 never received any traffic. And everything that's running on port 88 UDP, which I think it's Kerberos, one of the Kerberos ports, is not being used neither. So from this diagram, I can see that. I can see things as well, like if I'm using a production kind of environment, you deploy NTP on every server. Most of the time, those servers don't use NTP. You can see which server are actually still listening, so they are misconfigured around it. And if you do have load balancer configuration, and I don't have in this workspace, so I'll just show you another one, which does have load balancers. Let's take DB tier. So this is just a simple three-tier web app that we have running on Linux. That's the only reason we have this one. It has a load balancer in front of a database group. That's what we have. So you can see for every single host, I get the exact configuration that's referred to from the system. So it means that if you have, let's say, F5, Cisco ACE, let's take Cisco ACE in a Cisco world, which is, I don't think it's still out there. And then the idea is that you can see exactly which configuration applies. And, you know, for this VIP, and this VIP is 158, traffic is going to 3 servers. The main process is MySQL. These are the ports that are being provided. And you'll notice on this one here, on the bottom, 3306, I got 3306 via something. And the via is actually via load balancer. So I get all this information. That's why the side, what we refer to as side information, is critical information to us. And once you've done all that and you played around and you've kind of you're up to this to the application kind of level and you're happy with it, well, you can just export it. So you can just export and back up kind of the policy, again, to a JSON file. You notice, I'm just going to highlight it again, because there's no mention of Cisco in there. It doesn't say export for Cisco APIC or export for Cisco ACE or ACE or anything like that. It just exports to standard JSON. And this standard JSON is nothing more, in fact, than just a structure of the policies and the endpoints. So you want to create firewalls directly on Microsoft on Microsoft Exchange. You want to create firewall rules directly inside the Exchange. Take those policies, ingest them with PowerShell or something like that, and you can create your own environment. We had the case of customers, for example, using technologies we didn't support. They just take it, they take a Python script or whatever, and they just convert them to whatever platform they have. The good thing about that is that, like you saw, we can export in a standard JSON format. We can also import in a JSON format, meaning that the days of give us your requirements, we'll put them on the roadmap when it comes to support of third parties are over. What we do is we take a JSON file. Whoever can forward us the JSON file, if it's scripted or whatever, we really don't care. We ingest it, and then we process it immediately. And this information can be load balancer configuration. We take F5 natively as an example, HA proxy, Cisco ACE, because we still use them in IT. So we do pull this information natively in. And other information. DNS is one of them, because we cannot query your DNS servers directly. Because let's imagine you have a network with 30,000 endpoints. If I run this, I'm going to run 30,000 DNS queries at the same time. So your DNS servers might not like it. And that's the reason why we actually take the files rather than query the DNS. So just see them as zone files. That's all it is. We take routing information, so IPAM, that's the other name, that's how we just put it, and anything that's CMDB related. And that you have, again, JSON files on that. We're looking at direct integration with some partners, but for the moment, we're just going for the standard JSON. Few things around it. This is the moment be a data scientist kind of thing. The only things on data science, and I always have the problem with Chrome of those Facebook notifications. I have to find a way to kill them. Basically, your data science is limited to 2 cursors, and those 2 cursors are here. Right. Granularity and port generalization. This is how we tweak the machine learning algorithm. What we do, you tell us how big you want your groups to be. I want very small clusters, meaning server groups. I want a very large servers group. And that's the input the machine is going to take to process that. And the second one is, how open do you want us to be with regards to ports? I have ports 1, 2, and 5, for example. Should I do a range from 1 to 5, or should I do 2 ranges? And this is what you can tweak for the system to give you the information. So you see very simple things that you can do from there. Now, we've talked about simulation and you're just wondering, like, okay, and now? Now you notice I've showed you how to export the policy to send it to any other system. Most likely, you probably want to test it before you go to any other system. And that's why you can publish the policy to some kind of environment where we simulate compared to your network patterns. Keep in mind, we're seeing all the traffic as it flows into the platform. So it means that I can also take a policy and see, compared to the traffic running in your environment, what is actually happening. Is this traffic allowed? Should it be denied? What happens exactly? And that's what this view is giving me. And this view is provided around 2 areas. The first one is live traffic. So as the traffic is flowing through my network now, what would this policy do on my environment? Or you can test it to a specific period of time. Let's say that you got your annual report is running. You've been running Tetration. You got the information around your annual report dates. And you want to check if a policy that you're going to deploy is going to break your batch jobs that are running there. And you probably don't want to be called by the CFO 2 days before the presentation of the results there. So with that, what you do, well, you just select your dates, and we've actually tested it in Cisco as our annual report was end of July. We actually take the information there, we match the policies to this information, and we see what would happen. And those kind of processes that only run once in a while, I actually see it. And then I can decide, is it worth applying or not? Because like we're no superhumans. Like in the past, we used to fail about 4 times to get it right. And failing doesn't mean breaking the network. It just means we had to roll back or do something else, more investigation or things like that. And this is the kind of thing that we're trying to solve, so you can test before you do anything, then you're fine. Now, what do I have in this graph? This graph shows me permitted, misdropped, so something that is dropped and that shouldn't be dropped. Again, remember, we can deploy sensors, and those sensors can be physical or virtual. But if I see a sensor on one side, and I have the destination sensor, and I see a packet coming in on sensor on the left side, but never coming to sensor on the right side, most likely it got dropped. If you got the switches, we can even tell you why it got dropped. So that there is a little bit of benefit of having some Cisco hardware, you see, there. So we can give you more information around those things. Usually, permitted traffic, no one really cares. Permitted is by the policy, so should be OK. So let's have a look a bit of the escape traffic. And escaped is traffic, again, think whitelist policy model. I'm moving to an environment in which every single flow should have a policy attached to it. If it doesn't have a policy, it doesn't belong there. So if you have an escape flow, it means that either your network is not correctly configured. Think of the troubleshooting steps that you usually have, permit IP log, because you want to see what's happening, and we forget to remove it. So those are things that happen. If this happened, any flows would show up as escape flows. And say, OK, Remy, that's great, but now what? Now, the thing, again, keep in mind, we have all the data again. So I can look at every single packet that has gone through to know what traffic it was actually. And I can see here, I have actually a workstation, which is on our workstation network, which is talking to a database directly. It's bypassing the load balancer. And why would a workstation talk to a database directly? And those are things we see in the environment. Maybe it's a developer workstation. Might be OK. Maybe it's a user which is doing things he shouldn't be doing. You know, the kind of, I take an Excel spreadsheet and I try to hit directly a database server to pull information out. If it is allowed, well, you're fine. Just need to whitelist the flow. This is just going to modify the workspace and let you know, OK, it's fine. You can, this port is now allowed. So it's going to modify the policy for you for this flow to be allowed. And if it's not allowed, it shouldn't be allowed, then you might need to go to your network guys and have a discussion around how they're implementing the deny at the end of the policy each time. But again, you get information on that. Now, let's focus a little bit on the drop flows. On the same way, I can see what's happening for the drop packets. And I can go and I can take, for example, this is a nice peak. What happened in terms of drop flow? And I'm going to focus a little bit because up to unknown, I'm not too focused on, but there are load balancers to the database. That's something I want to look into. So I'm going to select this one, and it's going to refresh the chart for me with the information related specifically to those environments. So let's hide misdropped and escaped and rejected, because those are not the things we're really interested in. But let's focus a little bit on the misdropped. So I'm hiding the permitted flows, and I can see that I have a spike. And this spike is actually happening exactly at the same moment when I have a spike of traffic. So you know what? Instead of going and hammering down the security guys and telling them, you know, your policy is wrong, it's not working, maybe you should go and talk to the network guys and ask them, was there a problem in terms of capacity on this link for this moment? So instead of spending, again, the 3 weeks of troubleshooting hop by hop the ACLs to make sure everything works, what you just need now, you know, before you spend all this time, just check first the capacity management side of things. Again, as usual, all the details are available for every single flow you want to do, and so on. And then as we drill down, so from there you've seen we've taken an application, we've created an application map for it. Then this application map, we've tested it here. We have the possibility to export the policy and to export and to insert it in the network. On ACI, it's just a one command ACI toolkit thing that does it for you. On other platforms, those are things we're going to implement as well. You can script whatever you want around it. Again, everything is open on it. But now, what's the data? What are we actually getting and showing? And that's where the Wireshark on steroids comes in. This view is going to show you exactly every single flow that the system has seen. And to give you an idea, this system has 1.5 billion observations. Cisco IT production systems, 84 billion records. And the queries are exactly around the same timing. You'll see we have data since the cluster is actually born, 6 months of data you can see here. So all the data since we plugged in the cluster is there and available. I can go back at any point in time in those 6 months, have a look, check, and understand what happened there. And of course, I can search. So let's say kind of query, typical queries, long-running kind of information. So let's have a look. Let's have a look at every flow that has been running for more than 1 minute, as an example. So long-lived kind of flows, those are usually the flows that are more at risk in environments. So these are the lists. So I've got out of the 1.5 billion records, 48,000 records in 2 seconds, including the latency up to here. So it is a pretty nice result for this kind of platform there. And one thing you can see as well, which is pretty neat, you can actually get the processes attached to those flows. So let's say, I always take Hadoop as an example. So we have Hadoop running here. Hadoop is it's impossible to remember all the ports. There's just so many that you never remember which port is what. With the process name, I can go and check that. And let's focus on Yarn, on the resource server. I can add a filter there and update my query to show me all the long-running flows that have been running Java Resource Manager there. And then for every single of those flows, I can see the history of what happened exactly during the life of it. So I can see number of bytes transmitted, number of packets transmitted and received. But what's pretty interesting, especially for the application guys, I can see latency as well for a flow. And I can see 2 things when it comes to latency. The first one is I can see what's called the SRTT latency, smooth round-trip time, which is really TCP stack to TCP stack latency, excluding any application. So it means I can tell you your operating system from point A to point B is working with this latency there. What I can also show you is the application latency. And what we mean by application latency is more a measurement of the user experience. The user experience, what we're looking at is how long we received a packet for a request and we sent a response back. How long did it take for us to process and to send this response? I'm not doing instrumenting system calls or anything like that, so I'm not putting latency on the system. I'm using just good old kind of TCP measurements that I'm doing there, and I'm getting this kind of information out using an algorithm around it. So it means from this graph, I can tell you, you know what, this was the latency, this was your application latency, this is how it behaved over time, and I get all this level of details. So we're starting to get pretty interesting information there. But what we have as well is flow activity. You notice the blue bar at the bottom? The blue bar at the bottom is a kind of is a baselining method. What we're doing is we baseline the flow over a period, and we show what doesn't look normal. And we show what doesn't look normal in the form of peaks. Here, for example, you see a nice peak towards the bottom, meaning the flow has clearly underperformed at this point in time. So you can zoom into this period of time. Let's see if I selected it. So yeah, it underperformed pretty nicely. It's actually, there was no flow. You can see the kind of cut in data there. What happened? This is in our lab environment. Someone pulled a cable. And I can see it easily on the graph on the timeline. Something happened at this moment in time. It was between July 24th and July 31st. And this event happened around, sorry, I'm missing the date here. Let me click. See this. At 29th of September, sorry, it didn't refresh yet. Update. Here we go. So it happened on the 28th of July at 6:43 p.m. exactly. Now I can go back and see what happened there. And this information is there in a few months after. And I can go back to any point in time there. What I do have as well, I do have the actual command line arguments. Why do we have command line arguments? Make it simple, it's for Java. That's the reason why we do it. If you have a system running multiple Java process, HRMS, this kind of tools that are there, the problem is that each one is called Java. So when you want to get a process information, if you don't get the command line following it, you can't derive what it is. In this model, I can see which process is running, and I can see it was the node manager that was talking to Yarn there from the process information that I have here. As usual, all this I can search through as well. Now, and I got two more things to show you. I'll show you the exploration, and I'll show you as well a bit of on the sensors. Let's say I want the system to help me, because what I've showed you is that you know exactly where you are. Like, you know you have to look at a flow, you're looking for something, a pattern, something that's happening. In this mode, I'm not sure what I'm looking for. Is that something may have happened, maybe something that didn't happen there, kind of thing. What I can do, and forget about all those windows, there's way too much information here for it to be useful. Let's say I'm just interested in something very simple, consumer talking to a provider, and I'm interested in seeing what was the network latency between them. You see I can move around. So I'm just now showing you the latency, how the latency is spread across all the workloads in my environment. They're in a graphical way. And you can see that some of them have pretty high latency compared to the others. Most of them are there in the bottom, so every line is a flow. So the darker, the more flows. So you can see this information there. But now, I'm kind of lazy. I don't really want to go and look at every single flow there. So what I can do, I'll pause the loading. So you see we got 6,300 flows here. I can ask the system to point me to what doesn't look right. And if I click, I'm moving from 6,000 to 42. So the system thinks that out of those 6,000 flows that are running in the environment, 42 are of interest and should be investigated. And you can get the view, of course, for each of them. As usual, you can go, you can get the exact view, and it's going to put you the pointer to the moment where it is going. This one is actually interesting. See, latency is going up slowly. So most likely something is wrong on the system there. And system is just telling me, you know what, have a look around here. And the first one I look at seems that latency is slowly coming up, which may mean that there's something wrong with the operating system, or the load is picking up, or whatever. So I can get all this information there. In the same way, you remember we talked about the DNS one. Let's say I just want to search on port, a provider port, 53, for example. Here, if I start loading, it's probably better. Here, what I'm going to show you is all the communications in my environment over the DNS ports. So it seems like most users are using the DNS server, which is a Cisco corporate DNS, so it makes sense. But see here, there's actually one that's actually running Google DNS here. And I can select it to zoom in on it, go down. And it's always this IP address, so it's one of our Windows machine which is using Google DNS right now. So again, more information there. In those queries, you can figure out what you can do with it, like really just your imagination is kind of the limit. And remember, you'll be able to get all this through the APIs as well. So you can get all this information out. And finally, the sensors. This is a graph of the utilization of the sensors. And this view is kind of the same one as the one that you'd see in production there. I cannot show you production just for InfoSec reasons that I'm not allowed to, but the numbers and the ratios are about the same. This is the sensor average usage. And let's take a peek. Let's take this one. I can see that this sensor, the average usage, CPU consumption, of my sensors on a 15-minute average was 0.19% per core. Processing data, and it saw a total of 165 gigabytes of data over a 15-period interval. So it means I use 0.2% of a CPU to collect this. And you know what? In Cisco IT, we do the exact same for 10 terabytes of traffic. So the sensors are extremely optimized. Plus, you can see packet misses. What happens if a sensor throttles? Sorry, one thing I didn't probably insist enough, you define how much bandwidth you give us on the sensors. If you say we should use 3%, we will never go above 3%. And some customers want to give us 40% because they're critical about telemetry. Some of them, 1%. And we'll do with whatever you give us. If we do have to miss some packets, and you have to go far to miss packets, if we do have to miss some packets, we will report them there. So again, you're not blind if we're dropping information or anything like that. We actually tell you what's happening. We put instrumentation at every layer there. And that can enable you, when you search for a specific host, for example, I take my Varnish host, I can go down per IP address to traffic volume, host reputation. Is the host doing things it shouldn't be doing? Sounds this one does. And this one, yeah, the system thinks there are some hidden processes running on the system, so you might want to have a look. So they're not in DMZ, so I'm not too worried about it. Then you can see for each sensor again, bandwidth I'm seeing, CPU overhead I'm causing, how many flows I've exported, and so on. So again, the idea is be as granular as possible on everything. Again, all data you can feed out through APIs. So there is a lot of things you can get from Tetration. And just to kind of to sum up around it, we're really working towards the following use cases. So the first one is we want to see everything that's happening in your environment. And I mean absolutely everything. We want to store it, process it, and be able to go back in time. And storing and processing also means that when we decide to create new features, it means that the new features can also apply to data that's already stored on the platform. So you do get lots of information fed into it. It's easy to use. It comes in prepackaged and so on. No kind of knowledge you need around it. Self-monitors, don't touch. It will show you when it's not happy. It's going to show you in the dashboard some orange or green or red kind of thing. It can call home if you want to. Most customers don't enable it, but it's something that you can absolutely do. We keep it as open as possible. This is an open platform. You saw APIs on one end, data ingest in JSON, data export in JSON. So we try our best to make the platform very, very open, so you can expand on it and get more. And the fact as well that we do not require any hardware in your environment makes it very easy to deploy in your environments. You just need to deploy 2 sensors and you're up. Cisco IT, zero Cisco hardware. So in there, we're actually using it to migrate to ACI there. But so far, Cisco hardware, non-telemetry enabled. We'll put it this way. That would be unfair to say they're not using Cisco hardware. So they are using non-telemetry enabled switches. So they're just relying on software sensor, and they get all the information out of it. And they've been mapping out application per application and then migrating them. So there's been lots of information. It is field tested. You can see it has been officially announced on June 15th this year. We've been running it in Cisco since last year, towards the end of the year. So it has been battle tested there. And again, it's out of data path, so that we do not create any impact anywhere in your environment. And that's kind of it. I'll ask Maggie to come and join us for see who's going to get an Xbox. So I need to figure out that question, right? what can I give you as a question? Let's make it a kind of an easy one. So you're going to pick whoever raised their hand first and gets there. So everyone ready? Good. So what kind of hardware do you need to run Tetration? You better get it right.
You don't need any hardware.
Perfect, well done. So here you go, Maggie will give you the ticket, the magic ticket. So that's it. Do you have any questions, any clarifications, feedback you want to give on the platform? Question?
Have you created an Azure Resource Manager for this, to be able to plug it into Azure?
So the question is, did we create any Azure Resource Manager? So no, we didn't create anything specific to Azure. You can run workloads in Azure as long as if you have direct IP connectivity. Meaning, if you have some kind of VPN between Azure and your premises, direct connect or whatever, you're fine with it in there. Any other questions? No? Well, perfect. I'll be hanging at Cisco booth for a while after, so if you do have any specific things you want to cover, feel free to come and join us for a discussion. Otherwise, thank you for your time.